Hello again. I'm Scott Coyle. I'm providing the guest lectures this week for this week's lectures on RAS GTPase signaling. And so if you need to get in touch with me about questions about the course material, you can reach out through Canvas or you can email me directly at this email address you see here. And I'd be happy to talk to you about any of the material that we're going over. So let's hop into today's lecture. Um, but which is mostly going to be about examples of different RAS GTPase signaling pathways that you're going to see in the cell. But before we do that, I just wanted to give a quick review of what we learned on Monday because it's really critical to understand the material for the rest of the course. And that is the biochemical basis of RAS signaling and how it's able to act as a molecular switch. And so, just to remind you what we learned about on Monday, uh, RAS is a GTPase, so it's a molecule that can bind and hydrolyze GTP to GDP and perform this reaction over and over again. But this RAS GTPase is incredibly slow, so it's a super slow enzyme. And when RAS is bound to GTP, it is in an on state. And when RAS is bound to GDP, it's in an off state. Now, RAS can be converted from the off state to the on state by guanine exchange factors, which you can think of as activators for the GTPase. So these transition RAS from being off to on. And RAS is inactivated by GTPase activating proteins or GAP, which take the on state of RAS and convert it to the off state. And the way that GTP bound RAS is able to be on and communicate signals is through the binding of RAS effectors. So these are molecules that can only bind to RAS when RAS is bound to GTP, but not GDP. And because RAS is typically localized to the plasma membrane, this has the effect of recruiting effector proteins from the cytoplasm to the plasma membrane, which can communicate signals. And in other cases, it has the effect of allosterically activating those proteins to change their activity. And we'll go through examples of that today in specific signaling pathways. And so, really make sure you understand this core logic. There were some, if you're having a hard time with it, just jump back to the previous lecture. We did an example problem where we go through how these different molecules work. But as long as you understand this logic, you'll be able to understand everything that's going on in the course today. And just as a reminder to you, you've seen other GTPase GAP signaling systems in this class before. So in fact, this shouldn't be too new to you if you think about it. So for example, you've already learned about GPCR signaling, um, which essentially makes use of the same concepts of activating GEFs and inactivating GAPs, just in a different signaling context, that of the GPCR. And as you continue on in your studies, you'll see many other examples of GTPase GEF-GAP systems in other cellular processes. And so while we've been specifically talking about the RAS family of small GTPases involved in a lot of proliferative signaling, you'll find that small GTPase signaling underlies a variety of different processes like membrane trafficking, nucleoplasmic shuttling, vesicular trafficking, and perhaps most famously cell morphology, actin dynamics, and cell migration. And so, by really internalizing the logic and control of RAS GTPase signaling, you're going to be really poised to understand the logic that controls a whole range of different uh, signaling processes related to interesting cell biology. Um, and so, while the details differ among these different GTPase systems, this core logic is the same. And so, I hope you really will be able to internalize that logic by the end of this week.